we are going to design step by step different performance aspects of the amplifier. And if we put them in the right order, every time we have done some performance aspects, we need to redo it later because we did something else and it affects it again. So let's go here. We have the order of designing, which is now very important, and we have independent performance aspects. That's what we want. So the type of amplifier, we have seen in a previous presentation, there were 9 types of amplifiers. If we look only to input impedance and output impedance that we might want from such an amplifier. And if you also look at port isolation, we had even more types of amplifier. But that is what I mean with a type of amplifier. The second is the gain. The gain, we will define, it can be designed. Of course, this is associated with the type, but it can be designed independently from the type. Then the noise. After we have designed the gain, we found the design equations for the gain. We can design or find design equations and setup considerations for the noise performance. Next step, power efficiency and clipping, which is voltage and current drive capability. Sometimes you put them in one, but basically there are 2 steps. If you don't have means to create the power, to let the power efficiency be good enough, there is no technique to make it better. If power is lost, there's no technique to get it back somehow. So clipping is the same. If your amplifier is clipping, you have no technique, no error reduction technique. So noise, power efficiency, and clipping are first in the list. Then the small signal bandwidth. We will find out that we have means to increase the small signal bandwidth or adjust it to the correct value after we have set the noise performance requirements for power efficiency and clipping. Then the frequency response. So this is the small signal bandwidth is only the bandwidth. It's like it should be so and so many megahertz. Frequency response is like, is there peaking allowed? What kind of filter is it? Is it a constant group delay filter, or is it a Butterworth maximally flat magnitude filter, or another type of filter? Then the weak nonlinearity. This is mainly because we cannot check the performance of an amplifier if it is unstable. So we must have the correct frequency response before we are going to do something about investigating nonlinearity. Then the temperature stability, we have means to correct it, so that can be at one of the latest points. And how are we going to do this in, let's say, the structured design courses and later on only in this course? Well, the feedback configuration will define the type. The feedback network sets the gain. The controller is responsible together with the feedback network. So we already look a little bit at the noise with the feedback network, but the controller input stage and the input port properties of the controller are relevant for the noise. Power efficiency and clipping is then the output stage. Small signal bandwidth is a loop gain pulse product. We'll find out what is that. It can be set by the number of stages or the number of controllers. The frequency response, we are introducing frequency compensation techniques to get the right frequency response. And while doing so, for example, we will not affect the noise or the power efficiency. We will not throw power away or increase noise when we do frequency compensation. This is what orthogonal design means. And then we have weak nonlinearity. Then we are going to study the differential error to gain ratio and see what means we have to correct it. It can be independent of the previous ones, and the DC stability. So this is the sequence that we will do. This is called the house of quality. It comes from quality function deployment, and in the roof here, you can say on top, where are there possible interactions between some design steps? Are they positive, negative, or undecided, positive or negative? For operational amplifiers, it looks like this. We are focusing on the limited number of aspects. We are not studying weak nonlinearity, and 4 of those aspects relate to the choice of the operational amplifier. So from 4 of these aspects, we are going to derive design equations and said, okay, for noise we need this, for drive capability we need this, for bandwidth we need that, etc. So that is how we are going to design in this course negative feedback amplifier step by step. And if we do a next step, we don't affect the results. We don't change the results from a previous step, because then we are in design loops, and that is something you don't want to have.